The final component of our model are the ABJK terms. These are the terms that will capture the degree to which there is an interaction. To see what these AB terms are equal to, let's imagine what the world would look like if we only needed the terms we've found so far. That is, the terms that are due to the average effect of factor A and the average effect of factor B. And let's do this graphically. So here is the average effect of route. It is the case that on average, it was slower to go on La Jolla Village Drive than to go on Gilman Drive. Here is the average effect of time of day. It is the case that on average, it was slower to go at 8 a.m. than 9:30 a.m. Now what I'm going to do is an orthogonal projection. I'm going to take the slope of that time of day effect and I'm going to project it at the heights of the route effects. That is, I'll just take that line with its slope and put it at the height of y bar dot 2 dot and at y bar dot 1 dot. Now, if we were to have a world like this, if those were the actual group means, notice this would be a world where there isn't an interaction. That is, the effective time of day would be the same for each of the different routes. It would happen to be the average effect of time of day. Notice, at Gilman Drive, we have, in this case, the average effect of time of day. It's a little bit faster to go at 9:30 than 8 a.m. And at La Jolla Village Drive, we have the average effect of time of day. It's a little bit faster and the same amount faster to go at 9:30 a.m. than at 8 a.m. So if it really were the case that there was no interaction, that the effective time of day was the same at both of the different routes, these are the means we would have for our groups. Now these are called the purely additive factor effect means. So we have a lot of notation here. So it's y bar PA dot JK. And notice that these are the terms or the means we would find if we didn't have to add in the final component we're looking for, the ABJKs. And these are means that would occur in the world if there really was no interaction, if we could describe the mean for each of those four groups on simply the basis of the overall average effects, the A sub j's and the B sub k's. Let's take a moment to look at how we would find one of these purely additive factor means. Let me draw in the grand mean, and I'll put in the value of A and B for each of the different means. Let's consider just one of these, the y bar PA dot 21. That is just the purely additive mean for 8 a.m. on La Jolla Village Drive. Well, we have two terms to add, so we have the B1 and A2, and we're going to add both of those to the grand mean. So let's start with the A term. A2 is equal to 63. So that brings us from the grand mean up to the overall average for La Jolla Village Drive. Then we have the beta term, or the B term that we're estimating with our sample. So B1 is equal to 16. So we'll add 16 to this value, and that gets us to the purely additive mean, the mean that would occur if there really were no interaction. So these terms, the purely additive factor effect means, are what we obtain in our model if we don't have those final components, the ABJKs. Those are what capture the interaction or the deviation from purely additive factor effects. Let me show you what I mean. So here are those purely additive group means. Let me move some of these around so we can draw in our original sample means. So these were the original sample means that we actually observed in our data. And remember, we knew from the outset that there was going to be some interaction here. We already saw that we couldn't describe the effect of time of day independent of which route we were on. Again, if we look at just La Jolla Village Drive and the group means, we can see that the effective time of day is for it to be a little slower at 8 a.m. than at 9:30. But the effect of time of day at Gilman Drive was different. At 9:30, it was a little slower than 8 a.m. So we already knew that we couldn't describe a factor effect without referencing the level we're in of the other factor. And these purely additive effects, the ones that we found simply by adding up the A's and B's to the grand mean, are the means we would get if there wasn't an interaction. So it is going to be the deviations from the purely additive effects that captures the interaction. So let me actually add in those deviations. There is a difference between the purely additive mean and the observed sample means. And this was the interaction. So the interaction between factors was the degree to which the effects of one factor depend on the level of the other. And a completely analogous interpretation is the interaction between factors is the degree to which the mean for treatments differs from the additive effect of factors. And let's remember what the additive effect of factors is. If we simply look at the margins, at the overall effect of time of day and Gilman drive, and then add up those marginal effects, that gives us the purely additive means. And we have deviations between the purely additive means and our actual group means. And that deviation will yield the AB terms. So here are the purely additive factor effects, which we found from the sum of the y bar ... plus the marginal effects, the AJs plus the BKs. We have the actual treatment means, the y bar .jks, the ones we actually observed, and the difference between those will yield the ABJKs, literally the deviation from purely additive factor effects for each of our combinations of factors. So in each of our combinations, time of day by route, we have an AB term. Let's look at one of these. The AB21 here is the deviation for La Jolla Village Drive at 8 a.m. between the purely additive, that is the mean we would find without an interaction, and the actually observed mean. Now you may notice something about the terms we have. We only have the value 24. Sometimes it's negative and sometimes it's positive. That should give you an indication that these terms are not independent.